When I was first starting to try to understand the energy system side of the game, I quickly realized that almost everything out there was just in a physiology textbook. I had a really hard time understanding how to connect the pieces of the energy systems into the actual training that I was doing in order to help people improve their conditioning. So, my goal in this lesson is not to dive deep into the physiology of energy systems, but it's to give you an overall better understanding of how energy systems work, and then we'll follow up with subsequent lessons on how that's tied to movement and mental performance and the bigger picture of conditioning. So, to get started with that, let's first talk about the fact that everything in your body starts with energy, and that means this molecule, ATP, or adenosine triphosphate. This is the body's energy currency. It basically runs every single cell throughout your body. This means from the muscles that you have contracting to propel you around to every cell in your body that needs to do some sort of function. This is the currency that they are running, the energy currency. There is no other energy currency. There's no other thing that provides energy. It's just ATP, and it breaks apart, creates the energy your body uses, and that's how our metabolism works. Now we have two broad pathways, two energy ways, or broad pathways of making this happen. This is the aerobic system, which I'm sure you're familiar with. This produces this ATP through aerobic or oxidative, oxygen-dependent processes. And then there's the anaerobic energy pathway, which produces the energy without the oxygen. And that's really all they differ in is one uses the oxygen, the other one does not. But there's a bit more to it than that, which we'll cover here in a second. Now, the other thing to recognize here is that there are two big pieces of this. The first is the energy production itself, and that comes down to, like I just mentioned, the energy system development that you have. So a higher level of aerobic energy production will produce energy differently than if you have a very high anaerobically developed system. So how your energy systems are developed play a key role in your energy production. A big piece of that is muscle fibers. So the muscle fibers, in terms of movement and in conditioning, are what are going to dictate essentially where the energy comes from, because we can train our muscle fibers to be more aerobically dependent or more anaerobically dependent. And we typically tend to think of this in just this fast twitch, slow twitch paradigm. But it's important to understand that muscle fibers exist in a spectrum from slow to fast or from anaerobic to aerobic, and they don't just all fall into one or three broad categories. There is a spectrum of fibers and energy that runs across all of them. So we can train that, and that's a big piece of what we're doing here. Now, of course, nutrition plays a role. So the foods you eat are going to dictate some of how this happens, as different foods are more well suited to different types of metabolism as well. But it's important to then connect this to energy expenditure, because as we're going to cover in the next couple lessons, your movement capacity, your skill and technique, and your mental performance are going to drive how much energy you need to expend, which of course means that's how much you have to produce. So energy expenditure is tied to energy production is tied to energy expenditure. And the lower the cost of being able to do something, the less energy you have to produce in order to be able to do it. Now, when it comes to how much energy we actually produce and how it gets produced, we have to understand the metabolic engine of performance. And the biggest thing to understand here is that our metabolism, our body, was designed to have a trade-off between how quickly we could produce energy and how long we could sustain that level for. So on the far left hand, we have what we call the maximum rate of energy production, meaning we produce energy very, very quickly. That ATP molecule gets produced rapidly. On the far right hand of the spectrum, we have the duration. How long can we sustain that level of production for? The further we go up the left, the faster the rate becomes, the less time we're able to sustain that for. And that means we can't produce maximum force and power for maximum time period. We can't run a marathon at the same speed we can run 100 meters at, and that's because of our body's inherent limitations. Now, the way that this works is your body has two branches or two pathways that are anaerobic. I'll show you here the anaerobic alactic and the anaerobic lactic, and the difference is how they work and how much power they can produce. So the most explosive, highest energy system we have is the anaerobic alactic. This is what's fueling very short-term explosive events like the weightlifting events, the powerlifting events, shot put, discus, track and field events. So this maximum explosive bursts for just a few seconds at a time. This is being fueled predominantly by that anaerobic alactic system. It's very, very short, but very high energy. Now we go a little bit further toward the right of the spectrum. We see the anaerobic lactic, and this system can produce energy from, for a very short period of time, up to about 30, maybe 40 seconds, before it'll start to diminish significantly as the body fatigues as a result. This is where sports like 100 meter, 200 meter, up to 400 meter are getting a pretty good amount of the energy. But again, the longer we rely on the system, the more fatigued we become. Now, to shift things a bit right here, we have a lot of sports, a lot of activities that require a combination of both. The team sports, combat sports, all these types of events where we have a strength, power, speed, or explosive component repetitively over and over again. The only way that's possible is with the combination of the anaerobic, lactic typically, and then the aerobic system, with the lactic playing a role depending on the sport itself. Anytime, again, you're relying more and more on that lactic system, you're going to fatigue very quickly. So when we see most sports that have a few seconds of explosiveness and we have 30 seconds or a minute of rest or varying rest periods depending on the sport, it's largely driven by a combination of the alactic system to produce the explosive force and power, with the aerobic system basically doing everything else. Now, as we go further to the right, we realize that the aerobic system is the foundation for all of these sports because it is what is providing the majority of energy for the majority of those sports. It's also fueling the recovery from those sports, and it's fueling the time in between those events. So the aerobic system is king. It's what we're going to focus heavily on Metamorphosis, I say, because of that. It's the foundation of the energy systems that are going to be required for the vast majority of sports out there. So yes, if you're an elite level powerlifter or you're an Olympic weightlifter, the aerobic system is certainly much less important than if you're a combat athlete, a team sport athlete, or you're just trying to live a longer, healthier life. But the aerobic system still matters, and we're going to develop that through the next 8 weeks with Metamorphosis. Now, it's also important to talk about here, part of the differences in these energy systems is the fuel that they can use. In other words, what foods and substrates they can turn into ATP. Now, the anaerobic side, the alactic, uses stored phosphates and creatine in the muscle in order to produce the ATP. The other half, the anaerobic lactic, uses carbohydrates, and you get lactate in the process. That's why it's called the lactic system. But you'll notice here the aerobic system is more metabolically flexible. So the aerobic system can take carbohydrates, fats, or proteins and break all of them down to produce ATP, which, again, because the aerobic system is fueling your life from really the second you come into it until the end, it means it's important that it can produce ATP from any energy source. If it wasn't, it wouldn't be a very efficient process. So the biggest thing to recognize here is that there are very few chemical steps for the body to produce energy anaerobically, and there are a lot of chemical steps for it to produce it aerobically. And that's why it takes longer. It's why it's slower. It's why it produces less overall power, but it's also why it can produce for a much longer period of time because it has more capacity to produce energy from the same amount of substrate. Now, on the aerobic side here, we're going to be training both two halves of the aerobic system, and this is what it comes down to. So the first half here is what we call the supply side. This is where your cardiovascular system is able to supply the oxygen throughout the body. So this is how your heart's developed, how your vascular network that carries the blood is developed, how your respiratory system is developed. All of these things will dictate how much blood and oxygen your cardiovascular system can pump throughout your body. This is a big piece of improving the aerobic fitness side. But there's also this other half, and that's the oxygen utilization side. And that's making sure the cells are able to pull the oxygen out of the blood and use it very effectively. And this comes down to the mitochondria, which are little oxygen power plants on your cells, and how well they're developed, how many of them you have, all these sorts of things. And both of these sides can be developed tremendously. There are huge rooms for improvement in both sides of this. You can tremendously improve how much blood and oxygen your heart can pump. Your body will build new blood vessels and networks and capillaries throughout your body. At the same time, you can increase mitochondrial density by 300-400 or more percentage points from where you started at. So the aerobic system has tremendous capacity for improvement because it's got a lot of these different parts, and each part in the system can be improved through training. So you'll see in the method section, I'll mention oftentimes which area we are training, kind of how it's impacting the aerobic system, which different pieces it's stressing. And effective programming is really understanding, again, how to build an aerobic development program that builds all the pieces. So if we look at the big picture here of how the aerobic system and the anaerobic system relate to performance, we can look at two different examples. All right, the first one is just an all-out period of exertion. So this is a paper where they looked at the energy system contributions to different distances of sprinting, again, at 100% effort. So 200 meter, 400 meter, 800 meter, and 1500 meter. Now you can see there, the black part of that bar is the anaerobic contribution, and the gray or lighter shade there is the aerobic contribution. So as I mentioned, 200 meter, 400 meter, they have a fairly strong, particularly 200 meter anaerobic piece. It's driving the speed, right? Those are speed events. But as soon as you start getting up into the 800 meter, 1500 meter and beyond, you can see that those are almost entirely aerobically driven, or at least they're the biggest piece of that is aerobically driven. So you really can't sustain, the aerobic or the anaerobic side very long if you are sprinting all out before the body has to rely on the aerobic system. That's why you slow down. It's basically why you run a slower 1500 meter pace than you'd run a 200 meter pace, because it's more aerobic, but it's the only way you can possibly sustain speed for that time frame. Now, the other side of the equation is, well, what happens if we produce power output over and over again with rest? And to understand how these two systems work together here, we can look at what's called the anaerobic speed reserve. Now, the anaerobic speed reserve is basically the difference between how much speed you can generate aerobically and how much speed you can generate anaerobically. And that's essentially what you're looking at here with 7 different people. Okay, so the total height there you can see is the total max speed that someone can produce. And of course, on the far left there, in order to get up to that 10 meters per second, that's going to have a pretty significant amount of anaerobic energy. Now, in this case, the graph here is a bit different. The black is how much speed someone can produce aerobically, and then the white is that anaerobic speed reserve. The maximum amount of speed they can generate, of course, is dictated by both of those. So what does that matter? Well, let's say we had a race or we had some sort of event. And let's say in that event, we had to produce about 6 meters per second of speed on average over a given time. Now, in this scenario, you can see that each person here would do that a little bit differently based on how much speed they could generate aerobically versus how much they could generate anaerobically. Now, if subject 1 was racing subject 4, let's say, for example, over time, subject 4 would sustain his or her energy and power output quite a bit longer because more of it was coming from the aerobic side. And you can see that by the fact that most of that energy at that 6 meters per second speed would be coming in the black, which is the aerobic side. Subject 1, on the other hand, would be relying much more on the anaerobic side because this person can't produce as much energy aerobically as subject 4. So in an endurance type event longer than, let's say, 30 seconds, chances are pretty high here that subject 4 would win, and particularly in a repetitive type event where they had to produce power, rest, and repeat, you would see subject 4 beat subject 1, other things being equal, very, very consistently. Now, the trade-off to that is, let's say that somebody had to get up to 9 meters per second. Well, in this case, only subjects 1, 2, and 3 can even get there. Subjects 4 through 7 are screwed. They're going to get blown away, right? They can't keep up with that pace. They can't produce that much force and power to generate that level of speed. They don't have the potential. So again, this is the trade-off. The more you want to go down the left end of that spectrum to produce as much force and power as possible, the worse your ability comes to sustain it. But if you develop the other side of the equation, the aerobic side, to one extent or another, eventually you'll be giving up some of that speed component and you won't have as much top-end speed. So this is where, again, these really specific energy system development for a given sport can get very, very detailed because it's going to depend on the demand for the sport and exactly where your strengths and weaknesses may lie. So again, this is not meant to be a sport-specific program. This is a generalized conditioning program. So while we'll train all the energy systems, we'll focus on building that aerobic foundation because that'll allow you to contribute the most amount to your performance in a variety of sports. And again, you can always develop those other systems as necessary as you progress beyond the program. So the big picture here for the energy system mix, the overall picture of how the body works is you've got these 3 big energy systems, or these 3 big pathways to create energy, the aerobic being the most dominant for the majority of activities. Anytime you are going all out, the crossover from anaerobic to aerobic dominance happens somewhere between 20 and 30 seconds. So as soon as you go longer than about 30 seconds, the majority of energy from that point forward will be coming from the aerobic side. Now, because you produce so much early on in that scenario, it takes till about 60 to 75 seconds or less or more, until the totality of the energy came from the aerobic system. So the bottom line here is very short, high-intensity explosive exercises will be predominantly run by the anaerobic side. But once you start going over 30, 45 seconds in any sort of prolonged all-out experience or event, you will be producing the majority energy from the aerobic side. And it doesn't mean the anaerobic's not important for speed. Of course it is, but just being aware that the aerobic system at that point becomes the most dominant player in the energy game. And then again, as you do something repetitively, more and more energy over time will come from the aerobic system as well. So again, the aerobic system is a really big piece of the energy production puzzle because it is so comprehensive in how it contributes to energy to a wide range of goals. There's really no sport out there that has no need for the aerobic system. Even the pure anaerobic sports, let's say a powerlifting event, you still need the aerobic system to recover. You still need the aerobic system to fuel the time in between reps so you can do another high intensity rep. And so it plays a role there as well, maybe not to the same extent as more aerobically driven sport. But the reality is, again, everybody needs to develop the aerobic system. It's a really big part of conditioning for the vast majority of goals. So that wraps up this section, this lesson. Hopefully this gives you a better big picture view of what energy systems are, how exactly they work together to contribute to performance, health, and wellness. And we're going to follow this up by talking about what happens after you produce the energy, and that comes down to movement, and then we'll follow up with mental performance to wrap up the M3 model of conditioning.